Okay, welcome to checkpoint 24. Question 10. A handkerchief that has been folded into a triangle is used to cover a picture. It measures 5 centimeters along its base and is 7 centimeters tall. The area of the picture covered by the handkerchief is blank. So I'm picturing a triangle with a 90-degree angles, base of 5 centimeters, and height of 7. And I remember the area of a triangle with our trig function as side angle side relationship. We have to have the area is equal to 1/2 the angle's adjacent side, so 5, times the angle's other adjacent side, 7, times the sine of the included angle, which is 90. So we're going to type it into our calculator, and we're going to type in 1/2 times 5 times 7 times the sine of 90, which is going to equal 17.5. Square centimeters. So the area of the picture covered by our handkerchief is 17.5 square centimeters. Question 9. In triangle ABC, side length AC is equal to 12, side length AB is equal to 6, and side length BC is equal to 9, and the h is the height. Remember that the area of the triangle with height h and base b is a equals 1/2 b times h. Use the trigonometric ratios and this formula for the area of a triangle to determine which equations correctly represent the area of triangle ABC. So our base is 9 and the height is unknown. So we have two options, since there are two triangles, to find a different representation for our height. So we have triangle from A, C, and I'm going to just label this point D. And I'm going to notice that there's C as our reference angle. So I'm going to use C as our reference angle because in the options given we have sine of C, sine of C, sine of C. And since C is the angle in the triangle ACD, that's going to be my reference angle. So if I label this triangle according to my reference angle, the height is the opposite side length. 12 is our hypotenuse because it would be across from our 90. And the reason I know this is 90 is because if the line comes, this angle is 90, then this angle is 90 since it's split is perpendicular to our base side. And so then this side length, which is not a total of 9, is our adjacent side. So now our goal is to find our height. So if I wanted to list out the options, we would have sine of our reference angle, which is C, would equal our opposite, is our ratio of our opposite side length to our hypotenuse side length. And we do know our hypotenuse total side length, and h is our height, so I'm going to use sine of our reference angle. So sine of our angle is equal to our height over our hypotenuse. Since I want a different representation for height, or I want to find its another label to give it, I'm going to solve for h. to find its equivalent statement. So h divided by 12. To move 12 to the other side, I'm going to use the multiplication property of equality and multiply by 12 on both sides. So 12 times sine of c is 12 sine of c is equal to h divided by 12 times 12 is 12h divided by 12. 12 divided by 12 is a form of a 1, so I can reduce down to 1. And I have 12 sine of c is equal to h. So 12 sine of c, since it's equal to h, that is another way I could label h. So I'm going to look for 12 sine of c. I have 12 sine of c here and 12 sine of c here. Now, question is to find the area of triangle ABC, and the base of the triangle ABC is 9. So I'm looking for 1/2 9 12 sine of c. So this is our option, one option to find the area of it. Now if we had used triangle ABD as our reference to find our height, then, and I'm looking at our options, sine of B, sine of B, sine of B. B is our reference angle, and if I label this, the height is our opposite side length, 6 is our hypotenuse, and I have an unknown adjacent side. So I'm asking myself, okay, I want to find the opposite, I want to find h, which is our opposite side length, and I know the hypotenuse. So the ratio, which trig function is the ratio of our opposite side length to our hypotenuse, and that's the sine. So sine of b is equal to the ratio of our opposite side length over the hypotenuse. And since I want to solve for h, I'm going to multiply by 6 using the multiplication property of equality again. So we have 6 sine of b is equal to h over 6 times 6 is 6h divided by 6. And this reduces down to a form of 1. So we have 6 sine of b, which equals 1h, or h. Alright, so by substitution I could use this label b sine of b, 6 sine of b, sorry that is a 6 sine of b instead of h in our equation. And our base for our triangle ABC, since that's the area that we want to find, is 9. So in this, by substitution, I would have area is equal to 1/2. The base is 9 times 6 sine of b by substitution, since it's equal to our h. 6 sine of b. So 1/2 6 times 1/2 of 6 times 9 times sine of b, 1/2 6 times 12 times sine of b, and 1/2 9 times 12 sine of b. Alright, the ones that are including the 12 are not associated with the triangle of sine of b, so those ones are off the table. The reason I can choose this one, even though the 9 and the 6 are in different positions, is because of the commutative property of multiplication, which means the order of the numbers can be switched when we multiply. So the commutative is 3 times 4 would be the same as 4 times 3, so the order can be switched. BR 9. Okay, so question 8. A quilt pattern is made by using 4 copies of the triangle of fabric modeled by triangle ABC, in which side length AC is equal to 3 inches, side length BC is equal to 4.5 inches, and the measure of angle C is equal to 60 degrees. Approximately how much fabric is needed to make a complete quilt pattern? Okay, so the question is asking for a complete quilt pattern, and that means we have 4 copies. So we first need to find the area of this, and then we need to total it up for 4 copies of this. So the area of our triangle ABC is going to equal 1/2, and this is our reference angle, and we have the length of an adjacent side, and we have the length of the other adjacent side. So it's going to equal 1/2 of an adjacent side times the other adjacent side times sine of the included angle, which is 60 degrees. And so we are going to use our calculator and type it in. We have 1/2 times 3 times 4.5 times sine of 60. And that's going to equal 5.845. And this is going to ask us approximately, so this is the nearest tenth. So I'm not going to round it till the very end, or else it increases how can I say this? It increases the error or inaccuracy in the final answer. So we're going to wait till the end to round. So now it wants to know our total for a quilt pattern. So the quilt pattern needs 4 copies of this triangle. So to make a quilt, we use quilt. Quilt is equal to 4 times the area of our triangles. And by our substitution property, we know that the area is equal to 5.845, and it keeps going. So we have our quilt total area is going to equal to 4 times the area of one of the triangles, 5.845. So then I'm going to go back to our calculator, and since this was the last thing that I had typed in, I'm going to just hit times 4. Now this is not rounded, which is what we want. So it's going to equal 23. The quilt total area will equal 23.382. And it's rounded to the nearest tenth, and the 8 would round this 3 up, so that this is saying that 38 is closer to a 40th than it would be to a 30th. So our answer is 23.4 inches squared. Okay, question. Let me just scan real fast. Alright, this one is actually going backwards, or manipulating our area formula, so I'm going to jump to question 6. Consider triangle ABC in which the side length of AC is equal to 7 centimeters and the measure of angle C is equal to 70 degrees. If the area of triangle ABC is approximately 6.6 square centimeters, what is the approximate length of side length BC? Alright, side length BC is an adjacent side to angle. And if these labels were different, say I had this same triangle, but the labels on the sides were different, say it was DEF, I can still use our area formula, because the area formula is the relationship of the side lengths to the angle that you're using. So this would be our reference angle. So then in the area formula, we would have one area is equal to 1/2 an adjacent side length, so which would be DF, the distance of DF, since I don't know it, times the distance of its other adjacent side. So that would be 7 times the sine of our included angle, 70 degrees. So just because the labels are different doesn't mean, still means we can use our area formula. It's just a relationship. And so that's how I can remember the area formula using our trig function, is because I remember the relationship, and I remember it as a side angle side. I have to have my reference angle and its two adjacent sides. So if we go back to this first question, then we can set up our area formula. The area is going to equal 1/2 an adjacent side length, which is unknown, and I'm going to label it as X instead of BC, because I feel like it's easier for me to remember X than BC. So then the times the other adjacent side length, which is 7, and we're going to multiply it by the sine of our included angle, which is 70 degrees, so sine of 70 degrees. Now, we know the area, so our area actually equals to 6.6. So by substitution property of equality, I can write 6.6 right there for our area. And if we look, our unknown side length represented for BC is represented by X. So now I need to solve for this. Since we have multiplication happening right here, I'm going to use the division property of equality. I'm going to do it all at once. So 1/2 is multiplying by X, so I'm going to divide by 1/2. 7 is multiplying to X, so I'm going to divide by 7. Sine of 70 is multiplying to X, so I'm going to divide by sine of 70. So I'm going to do it on this side as well. 1/2 times 7 sine of 70. Okay, 6.6 divided by 1/2 times sine of 70, times 7 times sine of 70 is 6.6 divided by 1/2 times 7 times sine of 70. And so that's going to equal 1/2 divided by 1/2 reduces down to a form of 1. I have X, 7 divided by 7, it reduces down to a form of 1. Sine of 70 divided by sine of 70 reduces down to a form of 1. So I have 1 times X times 1 times 1. So 1 times X times 1 times 1 is X. And that's going to equal 6.6 divided by 1/2, so 6.6 divided by parentheses, because we have more than one number in our denominator, I'm including parentheses around our whole denominator. So we have parentheses, and then I'm going to use parentheses for the 1/2 times 7 times sine of 70 times sine of 70, close parentheses, and I'm making sure it's in degrees again. That's going to equal 2.0067. So it is approximately 1 centimeter, 3 centimeters, 4 centimeters, or 2 centimeters. We found it to be approximately 2 centimeters. So side length BC is approximately 2 centimeters. Alright, and your quote for you today is by it's actually an anonymous quote. It is, if you can't find something good in your vocabulary to say about a person, smile. And there's your help.